Okay? This video is all about calculations regarding first law of thermodynamics closed systems. Now, when we say system, a system is the part of the universe on which our analysis is focused on. As you can see on the diagram, a system is enclosed in a circle, so the arrows pointing towards the system. Okay? These are the following parameters exerted on or towards the system as the following. We have work done to the system. We're going to use a notation as positive W. If the heat is applied to the system, that is positive Q. Now, if the system exerts work and heat, okay, work done by the system, it is negative W. If the heat is applied by the system, it is negative Q or negative heat. Okay? This is very applicable for exothermic reactions. Now, the formula for closed system is U is equal to Q plus W, or delta U or delta internal energy is equal to heat plus work. Okay? So we have the engineering applications for closed systems as the following. We have the non-flow systems, hydraulics, piston and cylinders, stamps, and then for the military application, we have guns and artilleries, and then enclosed gases. Again, if we're going to define the variables of the working equation for closed system as U is equal to Q plus W, U stands for internal energy, Q as heat, and W as work. The SI units for the following energies is in terms of joules. Now let's proceed with the first example as 3,000 joules of heat is added to a system and 2,500 joules of work is done by the system. What is the change in internal energy of the system? Now we are given with the following. 3,000 joules of heat is added to a system, So your Q now is equal to positive 3,000 joules, and the work is done by the system. Okay, so since the work is done now by the system, so W now is equal to negative 2,500 joules. So we are required to determine the change in internal energy, or delta U. As we are going to proceed with the solution, we are given with a system and we are required to determine the change in internal energy. Since the heat is applied to the system, Q now is positive 3,000 joules. And since the system exerts work, so our W now is in negative 2,500 joules. Our work is negative 2,500 joules. To solve now for delta U, or internal energy U, we're going to use the closed system equation as U is equal to Q plus W. Substituting now the following values, we have the following. U is equal to Q as positive 3,000 joules plus our work here, negative 2,500 joules, gives us 3,000 minus 2,500 joules, which is equal to 500 joules. Okay? So the amount of internal energy for this problem is 500 joules. Our next video is the second example problem for closed system.